today we'll first look one of the very what we say uh, leading work in this area. This paper is a this particular paper is well referred, and then we'll see some of the some PPT from the same thing. But let me start with this paper itself, right? So this is a algorithm for mining association rules. So if you recollect last class when we were discussing about association rule mining, so our so whatever we are doing with our this databases are all operational databases, right? Like or transactional databases. So it has several transactions, and as we fall back to reference like sales type of things, more specifically, say we consider a departmental store. So what is happening that for every transaction, specifically that checkout counter, they record the items are recorded, and with this barcode technology coming into play in a big way, so what we see that they will scan the barcode and finally bill is generated. In other sense, that whatever item set or the items individual customers are buying, those are recorded very standardized way, right? So barcodes, what will happen, the barcode will have that not only the item description with associated lot of other things, right? So these are being pumped into the backend database, say D, and what our objective is to find that whether there is a pattern in this items, right? Like say again with respect to a departmental store, whether there is a pattern that these items goes together, or if somebody buys these, also will likely to buy that and type of things. And based on that, as we discussed, the racks may be like bread butter racks may be nearby, and or sometimes it may be far away because the corridor you move for the butter, you try to take more items. That is a different management policy how they look at it. But nevertheless, uh, this whether this association between the items are there or not on a large database, that is a point to be. That is the pattern we want to mine, right? So for that, there are so what we see. So these are different thing of interestingness measure, right? So some of the things are maybe obvious, and some of the things are not that obvious, but we can find out those interesting features from mining these databases, right? So there are a few algorithms or a few approaches already proposed in the literature, but what we see that there are they takes a lot of time. But if we see, if there are items set say 5, so association maybe item 1 to item 2, item 1 to item 3, and that what we say uh, say one item set type of things. There can be considering 2 item set, and there can be several such things, right? So the combination, if we try to look at the combination, so that the combination will be pretty high to do anything sensible within a tangible time, right? So this in this work, which is by Agrawal and Srikant, so this is one of the leading work which is being referred in several textbooks. Rather, we'll see some of the like some people from some textbook. So being referred by textbook is one of the work where they propose a first algorithm for mining association rule, which is popularly known as a priori algorithm for association rule mining, right? So that will let us look into that algorithm today. So what we see that what we are looking at discovering association rules between items in a large database, right? For us, let us for the example we'll consider items of anything like departmental store. So if we have a formal statement that what we want to look at. So if there is a item set I, which has I1, I2, I3 item set of literals called items, right? So that can be considering the all items in a particular store, right? Let D be a set of transactions where each transaction, D be the set of transactions where each transaction T is a set of items such that T is a subset of this, contains this item I, right? Or if we have that whole, every transaction, it take a subset of this item set from this item set I for its as the literals. So associated with this such transaction are using identifier called transaction ID. Like transaction ID 1, 2, 3, 4, or in this example, you'll see 100, 101 type of things. So every transaction ID has a set of items, and we want to find out if there are such, say, in number of transactions. So what is the association between them? Right? So we may say a transaction T contains X, a set of some items I, if X belongs to this T, an association rule is implication of the form X implies Y, right? So where X belongs to I and Y belongs to I, and there is no common element between X and I. Right? So in other sense, I want to find out that, like, I cannot have that if I buy bread is with that type of situation, or bread butter, or it is associated with bread butter. Those type of things are we are excluding, right? So what we require, first of all, if I want to do this sort of association rule mining, or find out the association between the item set, first thing we want to look at is how frequent these things are there, right? Whether it makes sense of looking at those things, right? So that in other sense, that if I want to find out that whether this bread is associated with butter, right? Whether this bread butter out of this whole set of transactions, how frequent they are, right? So, or how many, what is the occurrence, right? If there are 100,000 transactions and bread butter, this combination appears only, or bread or butter, those items appeared only for, say, 10 transactions, that may not be interesting to look at those things, right? So that means what we want to see that from my transaction set, uh, how much support I am having. Like I say, 20% of the transaction having either bread or butter, right? Then, or item set 1, it may be bread, butter, jam, and other thing, coffee, etc., etc. So 20% of the transaction is having. So I said my support is something, this some level of things, right? Or in other terms, usually we in this case we refer as a item, that we say that support is 2. That at 2 cases thing is that support is 20. That means at least 20 cases these things are there. So that is the support, right? And one, out of those transaction where this so-called X union Y occurs. So we want to find out that how many cases that if something, say, P occurs, it implies that Q has occurred, or if the X has occurred, X has occurred, Y will occur, right? So that is the confidence. So out of that, how much confidence is there? Okay, so any association rule, X implies Y, will have a support and confidence associated with the rule. Right? Occurrence will be there. Once I have that, I can have a I can say that I have a this that it makes sense to look at this association rule, right? So that's why we are telling that the rule X implies Y holds in the transaction T with a confidence C if C if C% of the transaction in D that contain X also contains Y. Right? That means if in the C% of the things, if it contains say bread, it also contains butter and jam or butter and coffee. If I have to find out those items, say butter, coffee, etc. Right. So the X implies Y as a support of the transaction D. If 8% of the transaction D contains X union Y, that either X or Y. So given a set of transaction T, the problem of mining the association rule is to generate all associations that have the support and confidence greater than the user specified minimum support, like the like management or the user, how much minimum support it is specifying, and the minimum confidence, that is min conf, min sub and min conf respectively. So whatever we will be discussing with respect to the representation, so our discussion is neutral with the representation of the D, that how it is represented, whether it is a data file or it is a relational table or result in the base, anything, right? So it is neutral, that data is there. But in reality, in context of our database, is what we are looking at. The database is pretty large. I cannot take the data into the main memory as a one go, right? So if I need to fall back to this database for appropriate retrieving of the data to finding out this support and confidence of different association rules, what we are looking for, right? So one thing is important here, that it has to, as the database is large, so you need to fall back to the database. So appropriately, the sometimes what we'll see in the subsequent our discussion, not today, later on, that it may have to be properly indexed and things like that, right? We'll come to that later. Nevertheless, we have a large database at the package, right? If it is a very small database, we may not require so much things. We could work with more something bringing to the memory and working on that. Okay. So we are just highlighting the major thing. I will share the paper in your this MS Teams file folder. So there are some work on that, looking at the functional dependencies, right? But where we have that what already you have read, right? Are rules requiring strict satisfaction, right? So it need to be strictly thing. Consequently, having like dependency X implies X to A. One minute. Consider that any other dependency X plus Y implies A is redundant, right? So X implies A and redundant. But whereas in case of our association rule, these are pluralistic in nature, right? So the X implies A does not necessarily means X plus Y also implies the A, right? First of all, that one. And also holds because the latter may not have the minimum support, right? So my thing is that whatever I consider, it should have a minimum support. It is not like that all anything we are considering. Similarly, the presence of X implies Y and Y implies Z does not necessarily mean X implies Z, because may not have the minimum confidence into the things, right? So as these factors are there, so this we can say that it may not be the same way we cannot deal with it, right? So when we look at the problem, this overall into it is basically we divide into two sub problem. One is finding all item sets that have transaction support of the minimum support. If those if the item sets are not having the minimum support, we are not going to look at that mining of the things, right? So it is we are not interested in mining that data set, right? So it should be the minimum support, and the support support of the item set is the number of transactions that contain the item set, right? So if I have an item set I1, I2, I3, I4, or I1, I2, I5, I10, I11, etc., different item sets, which I am trying to look at whether there is any inherent relationship between the things. I am only looking for if it is having a different some minimum support, right? Item set with the minimum support are called large item sets. Right? So this term we use that these are the large item set because they have that minimum support, right? And all other are so-called like small item set. We are not interested in that. So for very large item set L, find other step is for very large item set. For every large item set L, find all non-empty subset of L. For every such subset A, output a particular rule that support A implies L minus A, right? If the ratio of support to the support L to support A is the at least the minimum confidence level. So what we are doing here, uh, uh, we are trying to have a say if my minimum support it is satisfied in the step 1 are say item I2, I6, I3, I4, say I6 and I10. Out of that we are going to find out all combinations where say I2 implies I4, I5, I6, I10, or I2, I4 implies the I'll say I6 and I10 because with the minimum I10 set, and then we want to find out that whether they have the minimum confidence into the things, right? So so things like while looking at that algorithm, we'll look at a first look at the so-called a particular example in this paper only, and then we'll fall back to this example in algorithm, which you will find that it is not a very difficult to understand, right? So we assume that the items in each transaction are kept in a lexicographically sorted order, right? So in every transaction items are in a lexicographically sorted order, right? So that typically say it is I2 will come before I3 and so forth, right? Uh, and it is a straightforward to adapt this algorithm in case where the database T is kept in normalized and each database record TID, transaction ID and item pair where TID is the identifier for corresponding to the transaction, right? So that is our thing that way I stored in the database, which updated that. So every transaction TI has a set of items, right? We call that the number of items in the item its size, and call an item set of K is a K item. Size K is a K item set. So one item set, that means if one item, one size is 1. If it is a 2 item set, there are sizes every set of size 2 and so forth, right? So we use the rotation C1, C2 to represent the K item set. Items set C consists of the so much items, right? So if C is x dot y, where x is the m is m set, we also y is having is an m extension of the y. Associated with each item set is a count field to store the support of the things. So whenever I have a different item set, I want to find out how much support it is having. Every step, if it is not within that minimum support, we drop that item. Okay. So rather, these notations which is followed in this paper, rather as many of the paper are based on many of the works are based on things, so you will find that this notation is valid for different literature. So this is the thing. So what we have, LK is the set of large key item set. So the definition of large, as we mentioned, that is it will have that minimum support, and those with minimum support, right? So has two field item and the support kind. So every that LK. CK, the set of candidate K item set, potentially large item set. So we will find out that which are the candidate for the next level of things, right? So each member of this set has two field, item set and the support count here also, right? So who are the item for the next level of this K item set? And CK bar is the candidate of K item set where the TIDs of the generating transaction are kept associated with the candidates, right? So this actually allows us to fall back to the database to retrieve the data, right? So the transaction ID with the CK bar, those with the candidates along with the transaction IDs, right? So this is the thing. So LK is the set of large item set. That means who are having the minimum support. CK is the set of K item set, potentially the large item set. So we need to again check and prune that whether it is a large item set. And CK bar is the candidate item set where TID of the generating transaction are kept associated with the candidates. Okay. Let us see the example first, then come back to this. Right. So okay. Okay, so let us consider as shown in the customized database in figure 3, that is assume that the minimum support is two transactions, calling this a priori generator, right? So we'll see that which generates this different this item sets level L1, L2, L3, right? Uh, at step 2, give the candidate item set C2 for the key equal to 2, right? So what we see later. So what we see that this is my overall transaction database, transactions in the database. So there is a transaction ID 100, 200, 300, 400, 4 transactions, and the items are say I1, I3, I4. These 3 items, and for 200 transaction ID 200, items are 2, 3, 5. And transaction ID 300, like that. So different items are there, right? 1, 3, 4, 5. So what we see, so some of the items are uh, having repetition. Like here we see that item 1 having a support of 2, whereas item 2 has a support of 3 and 6. And here we consider that minimum support is 2. So that means whoever crossing this 2 uh, count 2 will be considered as a large item set, right? So, and C1 bar is the this associated with the your transaction IDs, right? So if I have a one item set C1, that means Ck, if we refer K equal to 1, then we have for TID, with the TIDs, we have, these are the items 1, 3, 4, 2, 3, 5, 1, 2, 3, 5, and 2, 5. So out of that, one has, if we see, if we scan this database, then what we have, we see that one is having frequency or count of 2, 2 is having count of 3, 3 is having count of 3, and 5 is having count of 5. So 1, 2, 3 are there, whereas 4 having a count of 1. So it is pruned, right? Because it fails that minimum support criteria, right? Now with this L1, what we do, we try to do a L1 joining with L1, LK joining with a LK, and create, see what are the different items set, right? So 1, 2, 1, 3, 1, 5, 2, 3, 2, 4, 2, 4, 2, 5. So these are the possible items that is candidate for the 2 item set, that is where K equal to 2, right? So one thing is ensured. So if it is a K item set is having a support of crossing the minimum support, all subset will have a will also satisfy the minimum support. But other way is definitely not true, right? So here what we see, if I have a 2 item set 1, 2, the support, if you look at the database, so the support is 1, right? Whereas if it is a item set 1, 3, the support is 2, 1, 5, support is 1, and so on and so forth. As our minimum support is 2, so again we prune out this 1, 2, and 1, 3. So the candidate with the this so C2 is the candidate, so C2 bar is associated with the your mm, transaction ID. So what we have that so it is connection 1, 1, 3, so for 2, 3 it is 200, 1, 3 it is 100, and if you have this similarly 2, 3, 2, 5, and 3, 5, those are so these are the transactions what we need to find out these 2 item set, right? So based on that, we have these 2 item set as 1, 3, 2, 3, 2, 5, and 3, 5. So if you am working with the 2 item set and try to find out this association rule, that means what is the confidence of 2 item 2 implies item 3. So those things I can do with help of this. These are my frequent. These are my large item set. That means which satisfies the minimum support criteria. Okay. So we generate, initially it was 1 item set, then this 2 item set were things. Then I want to look at that what are the 3 item set which satisfies this particular criteria. Okay. So what are the candidates? So sorry. So again we have these combinations of again joining. Then we have that out of that the candidate is 2, 3, 5, where is the, okay, let me go up. So having 3 item set, so out of that what we have, so 1 is 1, 2, 1, 3, 4. 4 is not a have the minimum support. It is not a large item set. So in this case, we have 2, 3, 5 is the only 3 item set or k equal to 3 with a support of 2. Right. So if we want to associate with the transactions, so it is having 200 and 300. So these are the two transactions which need to be looked in, or which need to be accessed for this 3 item set. Right. So and what we see that there is a support of uh, 2 for this. So in case if for our k equal to 3, we have 2, 3, 5 as the 3 item set. Now what there is the algorithm stops here because there is no way to again generate the 4 item set and so on and so forth, right? So same thing if we look at that a priori basic algorithm, it deals with it. Okay, here is the so L1 is the large 1 item set. So it is so all the 1 item set. So for k equal to 2, L minus k not equal to so that is null, k plus plus. So we generate that candidate keys by a priori chain of the thing, considering the L k minus 1, that is the previous k minus 1 item set to generate the k. So for all transaction t in D to begin ct equal to subset of ck into ckt. That means it is candidates containing the t, right? So for all candidates c in ct, do that c equal to count plus plus. So and so if we consider that C in CK, those C in L, those candidates in the those items in the candidate in the L, where C dot count is greater than the minimum support, right? So this way we have this. Then finally we answer is the union of this all k equal to 1 of the things. So these are my frequent item set over which I can do this mining, right? So that means taking A implies L minus A. The support is there. We want to find out the next step to find out how much confidence is there in that particular association. So if it satisfies minimum support and confidence level, so we say this association is this association rule is meaningful. Meaningful in the sense this association rule need to be looked into how it will be used by the for the decisions making support. That depends on that how the management wants to take it, right? So, so this is the basic a priori thing. We just want to let me just based on that. Let me stop this presentation and check. Sorry, oh, I should not have closed this. So this is one PPT. I will say that this is from that data mining concept and designed by Hanan Kamba. This is also a very well-known book. I will go to that part just to. So as we are telling that frequent pattern, a pattern is a set of items, subsequence, substructure that is there, and what we want to find out is the association rule. Like same way, item set a set of one or more items. K items set is that is I1 or x1 to xk. So support count of x, frequency or occurrence of the item set x, right? and is the fraction of the transaction that contains. So what is the absolute support? That means how much the frequency of occurrence, as we are talking about that the support is 2, or it can be relative. That means the fraction of the transaction which is where this item is there, right? The item set X is frequent if excess support is no less than a minimum support. That means it is having the minimum support or more than that, right? So what we see that the support is the probability that a transaction contains X union Y, right? And the confidence C is the conditional probability that the transaction X also contains Y. Okay. Uh, so that way here some example that is from the Hannan-Camber book, it is there. So what we can introduce, we see that if we want to tick all item sets and things like that, it will be a huge sub patterns, right? Which making any meaningful decision is maybe out of question. Right? So here we are not going into the detail. Anyway, I will share that. Those who are interested, you can look at it. As we are talking about this a priori pruning principle, so if there is any item set which is infrequent, its superset should not be generated or tested. So that means if a item set, say I 10 is infrequent, so generating a superset is meaningless, right? So it's it is also will be a infrequent, right? So this is the thing, right? Whereas a items other ways, other way also, as we have discussed, that if it is a frequent, then the other things also will be frequent. Okay. Uh, So and is the as the method as we discussed, they scan the database DB once to get frequent one item set, right? That has to be there, right? First that one item set, generate K plus one item set from the K item set from the frequent item set, and test the candidates of the against the DB. Right. So terminate when no frequent items can be generated, right? As we have seen. So if we look at database is having 10 AC D, these are the database. So first item set we consider, and we see that the D having one support is pruned, and we have this item set with the support. Create those is not shown here, right? Uh, one minute, please. Hold on 1 minute. Just give me a minute. Sorry. Let me go back to that. So what we see that the CK k equal to 2, and then again we prune with the this which are less than the minimum support. The support is 2, and then we generate the k this next level, that is L, that is what we say that large 2 item set, right? And similarly, sorry. Similarly, from the CK what we get and the third item set, and then we find that there is no way to create next that there is a more frequent item set are possible, right? So this way, what we see that same pseudocode in more same that what we have seen is now given here, that initially create the LK equal to 1 frequent item set for k equal to 1 and so forth, between the k plus 2 candidate from the ki item set for I transaction T in the database. We need to look into the database. So increment the count of the k plus and go on doing that so long there are it is the exhaustive list. Okay, so let us stop here. So let me. So if you have any queries, we can discuss, or we'll fine. This is so. This is the a priori. Actually, there are different little some of the variants of a priori algorithm, like how to make it fast, and there is a FT growth and things. But we want to look at the basic a priori algorithm into the thing. Right? Okay. If you have any query, we can take up now, or we'll close the class today.